Thank you, Kin, to bring us such an insightful section. Next, I would like to introduce another special speaker from Red Hat. Red Hat is our sponsor of Hong Kong Open Source Conference this year, and thank you for their support. The topic today is Introducing Quarkus, a supersonic, subatomic Java framework. Our speaker, Peter Ho, is one of the solution architects at Red Hat Hong Kong. Coming from a full-stack developer background, Peter is passionate about new technologies and enthusiastic to share any knowledge that he has gained from his web development, Java programming, and public cloud architectural projects. With his extensive experience gained from large enterprise and government customers, Peter is now a certified Red Hat, Microsoft, Azure, and AWS solution and application architect. May I pass the time to Peter?
Hello everyone, this is Peter from Red Hat Hong Kong. So welcome to join this Open Source Hong Kong conference. So today I will be presenting you guys a new technology called Quarkus, which is a new Java framework for developing microservices and also Kubernetes and even serverless applications. So why is so special? Mainly because it is supersonic, meaning it's very fast, and also subatomic, meaning the footprint of memory is very, very slow. So I'm going to show you how this is being done with Quarkus. So without further ado, let me just go through the agenda. So coming up, I will be comparing the traditional Java and also Quarkus to show what are the problems and also what are the pain points in using traditional Java, and why Quarkus is so special and what is the strength of Quarkus. And later on, I will be showing you a real live demo to showcase a bunch of new features and I think those features that are interesting to most of the people, right? So first thing first, let me just go through what is the problem of traditional Java. So if you have some Java development experience, then or you are the Java developer, then you will realize that traditional Java, you really need to have a application server, for example, Wi-Fi or other WebLogic, WebSphere. Those application servers tend to be memory intensive and also CPU intensive. So that's why people started to move towards Spring or Spring Boot, a lot more lightweight Java runtime, or even to other programming languages. For example, Node.js using JavaScript, or advanced people may try using Golang, right? But the problem still exists for Java if you tend to use those called lightweight runtime. The memory footprint is still relatively large, and the startup time is relatively slow, especially in serverless environment. When we talking about serverless, when you want to deploy or when you want to run Java application on the cloud, for example, AWS Lambda, Azure function, that kind of stuff, it requires quick scale out capability, right? If you have a Java runtime that is very slow in starting up, then serving the traffic and doing the horizontal scale out will also not very very good, and also cause a lot of delay, right? So that's why people started to think, oh, why it behaves like this. The main problem of the traditional Java is something called just-in-time compilation. Well, in the traditional days, it is a good stuff. Actually, it is a good stuff because with just-in-time compilation, you are talking about all those dependencies are loaded and also configured in the runtime instead of in the build time. So that's why when you build a package, and you can run on everywhere, right? That is the strength of the traditional Java. Okay, that is okay. But when we when we look at this diagram, and you can see, oh, when I want to start up a Java, okay, there are a bunch of things that I need to do. First, load the configuration and do scan the class path, and let the Java JRE runtime to find all those model dependencies, and then later on start those fresh, start those application or memory pool, right? That takes a lot of time. That takes a lot of memory. But eventually, all of the stuff maybe your application doesn't need. But that really still need you to run it that way. In recent years, a new concept, well, actually not new, but in Java world is new. A new concept called ahead of time compilation comes in. With that, we move all those configurations, dependencies mapping, or even memory optimization, that kind of stuff, from runtime back to build time, right? So when we move those back to build time, then a lot of things can be done in compilation. So that's why it is called ahead of time. So what you will do with ahead of time is, oh, okay, I spend more time in compilation, but I spend less time or less memory in the runtime to get a optimized running environment, especially in a containerized like Kubernetes, OpenShift, or even serverless environment. When you have more lightweight runtime, that means you can pack more containers. You can pack more. You can pack more containers into the container platform, and also be able to scale out very quickly when the traffic comes in. So with ahead of time, and also with a technology called GraalVM, it can be done. So Quarkus is really the pioneer, I think, to Java framework who leverage this kind of technology, ahead of time compilation. So with that, it really enables you to build application that has a very fast startup time. For example, when you compare this one, traditional Java may take 4.3 seconds. With Quarkus and also traditional JVM, that means Quarkus plus just-in-time compilation. Okay, you can achieve more for example around 1 second. That is optimized already. But further, you can optimize using the GraalVM, using a native approach, ahead of time compilation. Quarkus plus native, talk about 0.0 something second. It's just instant startup, right? Memory. Okay, traditional Java, when you start a very simple hello world application, it already consumes like hundreds of megabytes of memory. In contrast, Quarkus with traditional JVM, just-in-time compilation, optimize, talk about 2 digits, 73 megabytes memory footprint for simple hello world application. But when you move further to native compilation, ahead of time, talk about just 12 megabytes. Comparing to there's a 10 times, more than 10 times reduction in the memory. So that's why with those two stuff, faster start time, and also reduce memory footprint, then you can have a higher container density in your container platform. You can pack more containers. You can have more resource optimization, and you can be able to scale out very quickly, rather than relying on traditional way to do that. Another benefit of Quarkus is something called live reload. If you have some experience in other programming languages, for example, Node.js, just give you a sample, they have something called hot reload, right? When you in a development process, you tend to change things very fast, and you want to try things very quickly. But in traditional Java, you need to recompile and then put it in a Tomcat and then put it in an app server before you can run it in your development environment. But with Quarkus, we can achieve similar things like other programming languages like hot reload. If you change something in your program, for example, if I add change some kind of Java code in my application, I do not need to recompile by myself in order for me to try the application in my development using Quarkus. What Quarkus will do it will automatically detect all the changes and then once it detects the changes, then it can recompile all the things for you instantly, very quickly, and then you can try the application. So that is, that speeds up the inner loop development. So that is very powerful. Another thing is Quarkus is basically a bunch of technologies that has existed for years. Basically, it's a framework that package all those existing technologies. For example, Hibernate, right? A lot of people using Hibernate as a database ORM, object relational mapping technology. Implementing REST services, we can have REST Easy to implement just RS applications. And for integration, maybe Apache Camel and other stuff like integration with Kubernetes, OpenShift, distributed tracing, that technology, Jaeger, monitoring, Prometheus, or even driven architecture like Apache Kafka, and more and more. So these technologies are listed here. Of course, they are not new, and they are very mature, and at the same time they are very popular, right? So these technologies or these extensions are already integrated into the Quarkus framework. That means you do not need to learn from scratch again. You can, if you know these stuff, then you can just go ahead and use it with Quarkus. There are no problems. And of course, the list here doesn't end here, right? There are a lot of extensions that I do not have the space to list those here. You can find those online. But the idea is, okay, you can use your the best of breed frameworks that you want, or the people out there. Those are the standards, the way that people develop the apps. For the IDE, then you can use Visual Studio Code, right? So for Visual Studio Code, it's a very popular code editor, and also for Eclipse as well. So you can or even IntelliJ. So I talk a lot, right? I talk the different benefits of Quarkus. Maybe you are interested to let me show you how it looks like in live. So that's why I prepared a demo for you. So in this demo, I will be going through three things. The first thing is we will look at the Quarkus project structure, and also the second thing is about debugging and also the live reloading. The third thing is about the startup time and also memory footprint, showcasing a comparison between using Quarkus in traditional just-in-time compilation versus using GraalVM and also Quarkus for the native compilation, right? Okay. So let me just switch to my personal workspace, which runs the Red Hat Linux machine. Of course, Quarkus doesn't just run on Red Hat Linux. You can run it on Mac or Windows or other Linux operating system. That is doable. Just in case if you are interested to those operating system. So the first thing is that I will go through the project structure. As you can see here, right, there's a lot of code here. But in order for me to use Quarkus, then you can go to the extension here. Basically, you search Quarkus. There's a extension available here. First thing, of course, you need to install this plugin so that you can have code snippet and also some command line tools that can help you in the development. Of course, you can just skip it, but I would recommend you to install it first, because it helps you to debug and also to integrate stuff with Quarkus and also the Visual Studio Code. So I've already installed this Quarkus plugin. So and also create a project. Let me just go through the Java code, right? In here, there's a source directory, and also there's a main directory and also the test directory. The test directory basically stores all the test cases there, right? And also for the source main, I have Java. There are 5 Java programs here. So the first, where is the main, right? Where is the main starting point? Basically, is this one, to-do application. What I'm going to build is basically a web application, which is a to-do list. There are 2 parts. The first thing is the front end or the web UI. Another thing is the open API based on REST protocol, right? So here I'm defining that, I need to build a REST application. That's why I have a to-do application class that extends the JS application base class, right? And then once I define this, I can start to define additional REST endpoints. For example, in here I can define index resource class, which states that whenever people hit the root path of this application, it will call the direct endpoint, which will return the to-do HTML page to the user to serve the HTML. So where is this to-do HTML? Basically, is in the resource folder, method inf, and also basically he's here. So to-do is here, right? So basically serve the HTML. So this is the first endpoint that I can define. The second endpoint is the to-do resource, right? In here you can see that basically whenever people hit the slash API endpoint, then there are a bunch of operations that can be done. For example, here get all the to-do list items, and then I have ORM object here called to-do, which I will go through later to sort list all the objects and then sort by the order, right? Sort by the order column. And then I have other path like slash ID, and then I can get the unique to-do item, and then also have post for post operations for creating the to-do item, and also of course update and also delete. Basically, it's just a very simple CRUD application. Okay. And another thing is there's under the resource folder, right? There's application.properties. Then you can define all sorts of application configurations here. One thing that is required by this application is a database connection. So that's why I have used the ORM model and also connected it with the PostgreSQL with these credentials and also settings, right? Okay. So this is the basic structure of a Quarkus project. So next, I will be showcasing how to start this application in the debug mode to set some breakpoints and also to showcase the live reloading. Before I do that, I need to start up my database because this application requires a PostgreSQL, right? So that's why I have prepared a shell script. Basically, I will run a container, right? In here, there is a Postgres container image that I need to start. So that's why I need to type the start database command and then start it. Okay, so it takes like seconds, right? Yeah, because it's basically a container. That's why should be very fast. Okay, so server started, right? So next, I will be running the application. So basically, I hit the Control Shift P in my MacBook Pro, and then type Quarkus, and then I can click the debug current project. Okay, so it will start to compile and then do the loading, right? Basically, in here it is using the just-in-time compilation. I'm not using the ahead-of-time compilation because for development, people usually tend to use just-in-time first. But in the runtime, in the production environment or in the deploy time, then people will switch back to use the ahead of time compilation to enjoy the faster start speed and also the lower reduced memory footprint. Okay, so the application has started there, so that's why you see there's a green bar down there in the Visual Studio Code. So I can reload this application. So you can see there are a bunch of sample data already being loaded. So whenever I reload the application, there's a bunch of logs, showcasing that I'm actually accessing this application. So the first thing that I would like to do is, change something in my application. For example, I do not want to show this, to-do item in this order. I want to show it in a reverse order. So how should I do that? I can go to this to-do resource, and then I find the code, right? Remember, there's a code that states that I need to sort by order, right? Okay, I'm unhappy about it, so that's why I oops, let me just undo this. Okay, I'm unhappy, then that's why I need to change something. Then I say let me sort it by descending order. Okay, and then I hit save. Okay, once I hit save, that's the beauty here. I watch it when I reload. So you see, immediately the Java application. So this is Java, by the way, right? Can actually reload the application almost instantly, and it will do the hot reloading for you. Okay, when I want to change it back, okay, and then save it again, and then hit the refresh again. So you see, back to the original state. I do not need to do any recompilation by myself. I do not need to put the jar or put the WAR file into a application server by myself manually. I do not need to run CI/CD pipeline to deploy it into a development environment to make my application can start testing, right? I simply need to just change the code and then refresh the browser, and then you can see your result immediately. So that is very powerful. Another thing is I would like to showcase how to debug, right? Because I have already installed the Quarkus Visual Studio Code plugin. That's why I can set breakpoints here. For example, if I'm interested to set a breakpoint in the update operations, just click here, right? And then just without any refresh, right? I can just edit, type something. And then you can see immediately I can debug by from the Visual Studio Code. I then just step over or look at the call stack or variables. You can see what is the ID and what is the object, and the title attribute, something like that. So you can start the debug in the initial process very quickly. Okay. So let me just end this and then remove the breakpoint. So that is the second part that I would like to show. And the third part I'm going to show is the comparison between just-in-time compilation versus the native compilation in terms of the memory footprint and also the start time. And let me just end this debug mode, right? End this, okay? And then start a new shell. And then from here, I can just execute the OpenJDK build shell. Basically, just a Maven command, Maven package to start the OpenJDK. That means just-in-time compilation. To show how much time I need to take for me to compile this application. So basically, it should take around like 10 or 20 seconds or something like that to complete this compilation, or only 15 seconds. But when I actually run this application later on, you will see it's kind of slow. But on the other hand, if I try the native one, basically I have another command, start native build. Basically, I specify a parameter called I want to build a native, and build the native runtime using a container build. That means the build environment is inside a container, right? So that's what. So that is the way that I would like to build. Start the native build. Okay. So if I hit enter, it should take around like 3 minutes or something. So I'm not going to run it because it takes some time. The reason it takes so long compared to the traditional approach is because, as I just mentioned, ahead of time compilation is moving a lot of stuff from the run time back to build time. So that's why build time takes more time to build. But the benefit of this is faster runtime execution and lower memory footprints. So let me just show you the build result. So here is the build result that I have ran before I started this presentation. So it took me like 3 minutes or something to build, right? Okay, so that is the first comparison. The second comparison that I would like to show is the startup time and also the memory. So let me just start the traditional one, the one that is using just-in-time and also using OpenJDK. Start the OpenJDK app. Start the OpenJDK app. Oops. Okay. So you can count. Okay. It takes well, it should. You may think it is fast, right? Maybe 3 to 4 seconds, right? Okay. But let me just show you how quick it is to use the native one. Oh, by the way, the command for this is, I can show you. It's basically run the jar, okay? Because the jar is already built in the target folder that I can just run using a very simple command. And for me to start the native app, I do not need to use the Java. Basically, it requires something called a GraalVM. So that's why in your runtime environment or in your development laptop or machine, you need to have the GraalVM installed in order to run the native build, which I have already done. Okay, I have already installed the GraalVM, so that's why I can just run this command. So just look at this. I'm going to hit the enter. So you see when I hit the enter, immediately all the logs, all the things are all being loaded. Let me just show you again. Hit again. Hit it again. There are no delays. Okay, but compared to the OpenJDK version, just hit the command. See, it takes some time. Even it's started the application, it also needs some time to load those dependencies. So that's why you can see the power here. Let me just load back the traditional Java app to see how it looks like in terms of the memory. I have already opened the system monitor here. I can sort it by the startup time. So this is the application that I just ran. So as you can see in the memory, it's basically a very simple application, just 1 to 2 CRUD operations. Already took you half of gigabyte of RAM, without any traveling, without any fancy stuffs. So let me just kill the process and start the app using a native approach. Okay, started. And then here's the app. You see, 31 megabyte. 31 compared to the traditional one. Traditional one, was using 500 something, more than 10 times reduction in memory footprint. So that's why you can pack a lot of stuff, in the container platform, lot more in your VM, in your container platform, or in your serverless environment. So that is a very powerful thing. So I will stop here in the demo. So that's all about the things that I would like to show. So that's all about the demo, right? So let me just quickly go through some of the recaps. What are the benefits of using Quarkus, right? First of all, Quarkus is really designed for containers, because container really requires a faster startup time, right? And also reduce memory footprint, which exactly match what Quarkus is hoping to achieve. And the second thing is about the developer experience. With the live reloading or hot reload function, you no longer need to do recompilation for every development changes to test your application. And the third thing is about the technology, right? The Quarkus is really a bundle or packages of old or more, from old and modern and widely used technologies. There are a bunch of extensions that you can find, and you can reuse your Java existing skills. For example, if you are familiar with microprofile, then it is really for you. So how to get started? Basically, it's very simple. There are 3 ways that I would suggest. The first way is directly go to quarkus.io /get started. There are a bunch of well-written tutorials for you to learn. Another website you can go to is the code.quarkus.io. Basically, it is a website that is similar to Spring Initializer, if you are familiar with it. And the third thing is about the hands-on online learning tutorial, which is provided by Red Hat. Then you can go to this website and start the learning. So thank you very much for joining this section. I hope you can learn something from it. And thank you and have a nice day.